Yet, of course, this would of course correspond. F naught is just one particular example. We can have, let's just say, some arbitrary transformation, which of course is still has a bilinear form. Rn cross Rn R. An abstraction of course, this particular example. And of course, this entails, of course, the symplectic forms, or symplectic mapping, if I'm not mistaken, which of course, symplectic form must be in bilinear form, and of course there are two particular properties that must satisfy. But moving on, one thing, of course, about the matrix representation for multilinear mapping is that if this multilinear mapping could of course be represented by an n by n matrix, we can call that A. And of course it's an n by n matrix. And of course, for the sake of compression notation, you can say that A equals Aij. And of course, as for our first example of matrix notation, we need to use the standard basis of a vector space. And for this abstraction, we can say that basis B is equal to vectors E1 through En. And for this particular matrix, the ijth entry of the matrix is equal to, and for this abstraction, for the matrix notation, we can use this bilinear mapping, this function. We can say that E is epsilon of the vectors EI, the pair vectors EIJ, of course, in accordance to the standard basis. And for two particular vectors and vector spaces, we had vector x and vector y. Well, this transformation, of course, represented by a matrix, is equal to the transpose of the vector y times the matrix A times the matrix X. And by writing the matrix representation this way allows, of course, one to study various other aspects of bilinear mapping, of course, by using the properties of matrix addition and matrix multiplication. Of course, this statement, in accordance to standard basis of a vector space, can be proven, of course, by showing that by writing out x and y as linear combinations of this standard basis, and by showing that the matrix multiplication, or showing that the transformation is, of course, truly equivalent. Of course, this, by writing this out, this, of course, provides convenience and, of course, a utility, in a sense, for studying also symplectic forms. So, now, I would like to move on to talking about symplectic forms. So, running out a bit out of room, so I suppose I'll go to another board. I had a lot of good stuff about symplectic forms, but